So we're still in 5.2 in Trig. We're on logarithmic functions now, but we're going to finish up some properties here and go over some more problems. This one is a funky property here, number 4. This is saying when you have an a, it's written kind of like an exponential form, but it goes to a log of a. It's kind of like this one. See how they crossed out? Well, these are going to cross out here. That's the kind of property I was showing you before. And the reason why that works is if you were to rewrite this, you just put the log out in front. If you put a log out in front there to rewrite it, it's log of the base equals x, and that's the same thing on both sides. So if you were to see this here, you'd be like, oh, those will just cross out, so 7 would be your answer. So with example 5, it says solve the equation. Okay. Sometimes these really mess with people's heads, but it's not that difficult of a problem. If you see that they both have a log on both sides, and you see that the base is the same, that's the key. The base of the logs need to be the same. If the log and the base are the same, you can just take whatever's inside and set them equal to each other and solve. Pretend like they aren't even there. So it's just 4x minus 5 equals 2x plus 1. So I would add 5 to both sides to get 4x equals 2x plus 6. I'd subtract 2 on both sides to get a 2x equals 6. Then I would divide both sides by 2, and we get x equals 3 as our answer. Example 6. Solve this one. Okay, this is where you have to know how to rewrite this stuff in exponential form. You're given a log. I need to rewrite this in exponential form. So I see that the base here is 4. So to get rid of this log, I'm basically going to put a giant 4 down here and down here to get the log 4 to cancel out. So this cancels out, leaving a 5 plus x left over, and that goes 4 to the third power. So remember, whatever the base is, it's boom, that goes to the fourth. That's 4. That's how I get 4 to the third. And a 4 log 4 cancels out, giving you a 5 plus x. So 4 to the third is 64, and then I would just minus 5 to both sides, and I end up getting 59 as our answer. Graphing logs. Okay, once again, you can use a graphing calculator to do this. You go to y equals. However, you need to remember, like I told you before, you can't plug this in unless you do log of the big number divided by log of the base. So that's why it's log x divided by log 3. That's what you need to type in on your graphing calculator in order to graph this. When you do, here's the table that you end up with, and I only picked some of the points that will give you whole numbers. I didn't pick any points that would give you fractions. That's why they're skipped all over the place there. So when we do this, I get 1, 0, 3, 1, 9, 2, and 27, 3 be way out there. Notice how there's also no negative numbers because now, instead of a horizontal asymptote like we were getting with those exponential functions, we're getting vertical asymptotes. Notice how it's coming really close to 0, but it's never going to touch 0. We aren't getting any negative numbers.
Scotty, beat me up.
Example 8. To graph this, you're going to do log of negative x over log of 3. So when you do that, on your table, this is what will show up on your graphing calculator. Once again, I skipped over all the decimals, so this is all we're looking at. So it's negative 1, 0, negative 3, 1, negative 9, 2, and this goes really close to 0, but it's all going to be negatives. It's the vertical asymptote happens to be right at 0 there. Okay? So example 9 now, to graph this, you're going to do log of the absolute value. Remember, your abs key is under math. Okay, so remember that it's log abs x, and then put an end parentheses, then divided by log 3. And this is the points that you end up getting. So take a look at your points to see what you end up getting. And the only error that you end up seeing is actually at 0. It's actually on both sides. The only thing you happen to have is that it doesn't touch 0. It's still a vertical asymptote there at 0 that it can't touch.
An enlightened man would offer a humble traveler shelter for the night.
Example
Higher conversation
10.
with a bowl of Cocoa Puffs.
So, graph this and graph this. They look the same, but they're different. Here's how they're different. This first one, this is like saying do log of x minus 2 divided by log of 3. This is saying do log of x divided by log of 3 and then put a minus 2 at the end of it. Okay, that's what it's saying to do. So please keep that in mind. This first one, keep in mind what I'm graphing here for you. This is log of x. So what we're going to see is how do these move and how do these shift. This is the regular graph of log of x. This is saying that you take all your points, and what makes that 0 in there? 2. So this means I'm going to move all my points over 2. This is like the transition section 3.4 that we did. Same difference. So I got to move this over 2, move this over 2, and move that over 2. So that's all that's happening. So when I move that over 2, boom. Now, where is my vertical asymptote? It's no longer at 0. My vertical asymptote is going to be at, you got it, 2. Alright, because right there, what makes that 0 is 2, so now my vertical asymptote is going to go to 2. This will go on forever, and ever and ever, so it's going to eventually go to infinity, just really slow. Kind of like a square root problem does go to infinity, just takes a little while. This one right here is saying, hey, why don't we take the original, and because it's on the outside, we move it down 2. So I'm going to move all my points down 2, is what this one's saying. Notice how the vertical asymptote is still at 0 because it's what makes this 0. It's what makes that x by the log 0. That's where you get the vertical asymptote, and 0 makes that 0.
Chunky, extra thick for extra flavor.
So to graph this log, it would be log of parentheses 2 minus x on top divided by log of 3. And these are some of the numbers that would show up on your table. So I'm going to plot those points, and there's the graph. Now keep in mind what makes this 0, positive 2. Because it's positive 2, that's where the vertical asymptote is. There's something else to keep in mind. Alright, and I'm hoping to finish up the rest of our notes here when we come back.